A dilation stretches or shrinks a figure to create a similar figure. Notice that's similar, not congruent. Therefore, this is not an isometric transformation. The scale factor of a dilation is the ratio of a side length of the image to the corresponding side length of the original figure. A scale factor is something you multiply by. Take a look at this dilation. Rectangle ABCD, the blue rectangle, is the pre-image. It is dilated to get the image of the rectangle A prime, B prime, C prime, D prime. Notice that the image is larger than the pre-image of the blue rectangle. Notice over here we have a scale factor and it shows that it is 2. This length right here from the center of the rectangle to point B is 12. And because the scale factor is 2, from O to B prime, it's a length of 24. 12 times 2 is 24. 2 is the scale factor. Notice when I reduce the scale factor, what's happening to the image? It is getting smaller. And when I make the scale factor 1 exactly, the image and the pre-image are exactly the same size. This length is 12 and this length is also 12. Notice when I make the scale factor less than 1, now the image is getting smaller. It is shrinking. It's the same shape, but it's not the same size anymore. These are similar figures. Notice that when I make the scale factor 0.5, that means 1/2, the original length of the length in the pre-image is 12, and half of 12 is 6, and that's the length in the image. Notice that no matter how I change the pre-image, the image will always stay the same shape. It will just be half as large as the pre-image. See, this length is 24, and now this length of the image is 12, half as big. I can reduce the scale factor even more, or I could increase the scale factor again and now make the image twice as big. That's a dilation. Let's try one of these on our own. Figure A is a polygon, and figure A prime is the polygon after a dilation from a center point of 0, 0. What is the scale factor of the dilation? So we remember that scale factor is something we multiply by to get to the image. Let's start by writing out the coordinates from triangle A. So notice that triangle A is the larger triangle, the one that I've highlighted in green. Let's find this coordinate for this point, 2, 4. This coordinate down here, 1, 2, 3, 4, -6. And the third coordinate, -2, -4. And now let's write down the coordinates for the smaller triangle, the image, the one that I've highlighted in orange. Let's start with the top point, like we started with the top point for the pre-image. This point right here for A prime is the point 1, 2. The next point we did was this lower point. That one is 2, -3. And the third point over here, -1, -2. Those are the corresponding vertices of the triangle. Now we want to ask ourselves, how did we get from this point in the pre-image to this point in the image? We could pick any of these points and any of the coordinates. For example, let's look at this x-coordinate as it compares to this x-coordinate, and we ask ourselves, the first x coordinate times what number equals the next x coordinate. Because remember, the scale factor is something you multiply by. So 2 times what number will equal 1? Well, we usually put a variable such as x in an equation like that to help us solve. So if 2x equals 1, we divide by 2 and x equals 1/2. It looks like the scale factor equals 1/2. But let's check it by looking at another coordinate. How about looking from -6 to -3? Notice these are the corresponding coordinates. This is the y coordinate and this is the y coordinate. So we ask ourselves, -6 times what number will equal -3? Well, let's put x for that unknown number. So -6x equals -3. Dividing both sides by -6, x equals 1/2 again. So it is true that the scale factor is 1/2. This image is 1/2 as large as the pre-image.